Okay, good morning students. Last session our discussion is about Calder's law. That is, we already told that the lambda 0m value of weak electrolyte cannot be calculated directly. For that we adopt an indirect method that is based on Calder's law. Calder's law states that the limiting molar conductivity or lambda 0m value of an electrolyte is taken as the sum of the ionic conductivities of anions and cations. For example, lambda 0m HCl equal to lambda 0m H plus lambda 0m Cl minus. And one of the application of this Calder's law, that is the first applications of Calder's law, it helps to calculate lambda 0m value of weak electrolyte. It helps to calculate the lambda 0m value of weak electrolyte. For example, lambda 0m acetic acid that we discussed in detail in the last session. And second application is it helps to calculate the degree of dissociation alpha, as well as alpha stands for degree of dissociation and dissociation constant K for weak acid. That is, first of all you calculate the expression for alpha equal to lambda m divided by lambda 0m, where lambda m is the molar conductivity at a given dilution, and lambda 0m is the limiting molar conductivity. And once you got the value of alpha, that is degree of dissociation, you can calculate the dissociation constant as K equal to C alpha square divided by 1 minus alpha. K equal to C alpha square divided by 1 minus alpha. These are the two major applications of Calder's law. Next we can do some numerical based question regarding the lambda 0m value of a weak electrolyte. That is the first question. Lambda 0m value for NH4Cl, NaOH and NaCl, ammonium chloride, sodium hydroxide and sodium chloride, are 129.8 to 48.1 and 126.4 ohm inverse centimeter square mole inverse respectively. Calculate lambda 0m of ammonium hydroxide. This is the question. That is, lambda 0m value, NH4Cl is a salt, NaOH is a strong base, again sodium chloride is a salt. Their lambda 0 values are directly obtained and the values are given as 129.8 to 48.1 and 126.4 ohm inverse centimeter square mole inverse. Then you have to find out the lambda 0m value of NH4OH. You know, NH4OH is a weak base. And by applying Calder's law, lambda 0m NH4OH equal to lambda 0m NH4 plus plus lambda 0M OH minus. For that, you are provided with lambda 0 value of three strong electrolyte. First one, lambda 0M NH4Cl. Applying Cold-Ratius law, it becomes lambda 0M NH4 plus plus lambda 0M Cl minus. Okay, the value equal to 129.8 ohm inverse centimeter square mole inverse. Put it as equation number 1. Second one, lambda 0M NaOH equal to lambda 0M Na plus plus lambda 0M OH minus. Here the value is 248.1 ohm inverse centimeter square mole inverse. Put it as equation number 2. And the third one, lambda 0M NaCl equal to lambda 0M Na plus plus lambda 0M Cl minus 126.4 ohm inverse centimeter square mole inverse. That is, put it as equation number 3. Once more I repeat, question asked like this. The lambda 0 value of 3 strong electrolytes are given, and on the basis of the lambda 0M value, you calculate the lambda 0M value of a weak electrolyte. For that, this is our required equation, lambda 0M NH4OH, and these 3 equations are provided. And based on, by applying suitable mathematical operations, that is, in our required equation, cationic part is NH4 plus and anionic part is OH minus. That is, the first equation contains NH4 plus and the second equation contains OH minus. Okay, then equation 1 plus equation 2 minus equation 3. Equation 1 plus equation 2 minus equation 3. That is equal to lambda 0M NH4 plus plus lambda 0M Cl minus plus lambda 0M Na plus plus lambda 0M OH minus lambda 0M Na plus minus lambda 0M Cl minus. Clear? That is, the same operation is applied in the case of lambda 0M value, that is 121.8 plus 248.1 minus 126.4. That is here and the remaining thing is lambda 0 NH4 plus plus lambda 0 OH minus, that is equal to lambda 0M NH4 OH. That is the question, and the final value becomes 2 equation 1 plus equation 2 minus equation 3, 251.5 ohm inverse centimeter square mole inverse is the lambda 0M value of weak electrolytes such as ammonium hydroxide. Then second one, calculate the lambda 0M value of acetic acids, acetic acid CH3COOH given lambda 0m HCl, lambda 0m NaCl, and lambda 0m CH3COONA are 426 ohm inverse centimeter square mole inverse, 126 ohm inverse centimeter square mole inverse, and 91 ohm inverse centimeter square mole inverse. That is the second question. Calculate the lambda 0m value of ethanoic acid or acetic acid given lambda 0m HCl, lambda 0m NaCl, and lambda 0m CH3COONA, sodium ethanoate or sodium acetate, are 426 ohm inverse centimeter square mole inverse, 126 and 91 ohm inverse centimeter square mole inverse. That is, we have to calculate lambda 0m ethanoic acid CH3COOH equal to lambda 0m CH3COO minus plus lambda 0m H plus. Okay, this is our required equation. And the given equation lambda 0m HCl equal to lambda 0m H plus lambda 0m Cl minus, the value is, what is the value? 426 ohm inverse centimeter square mole inverse, equation number 1. Lambda 0m NaCl equal to lambda 0m Na plus lambda 0m Cl minus, the value 126 ohm inverse centimeter square mole inverse. Lambda 0m CH3COONA equal to lambda 0m Na plus lambda 0m CH3COO minus, third equation. And by using the three equations, that is equation 1, 2 and 3, how you will reduce the expression, how you will reduce the required equation from the given three equations. That is, in our required equation we need CH3COO minus as the anionic part and H plus as the cationic part. The first equation contains H plus and the third equation contains CH3COO minus. Therefore, here we adopt the mathematical expression as equation 1 plus equation 3 minus equation 2. That is, equation 1 means lambda 0m H plus lambda 0m Cl minus plus lambda 0m Na plus lambda 0m CH3COO minus lambda 0m Na plus minus lambda 0m Cl minus. That is, plus lambda 0m CH3CO minus lambda 0m Cl minus plus lambda 0m Na plus minus lambda 0, and here we get lambda 0m H plus lambda 0m CH3CO minus, that is lambda 0m CH3COOH, that is lambda 0m value of acetic acid. And next is how we will find out the lambda 0m value. For the first one, the value is, what are the values? 426 plus 91 minus 126, isn't it? 426 plus 91 minus 1 26, that is equal to 391 ohm inverse centimeter square mole inverse is the lambda 0m value of ethanoic acid or acetic acid. Okay? Normally, what are the operations that we adopted for adding the different types of equations? Same operations applicable in the case of lambda 0m value also. The next one, determine the molar conductance of a solution or lambda 0m MgCl2 magnesium chloride at infinite dilution, or lambda 0m MgCl2, that is enough. Lambda 0m denote means at infinite dilution, given that lambda 0m Mg2 plus equal to 106.12 ohm inverse centimeter square mole inverse, and lambda 0m Cl minus equal to 76.34 ohm inverse centimeter square mole inverse. Here, you know, lambda 0m MgCl2 equal to lambda 0m Mg2 plus 2 into lambda 0m Cl minus, because one molecule of magnesium chloride contains 2 chlorine atoms. Therefore, it is equal to 106.12 plus 2 into 76.34. 2 into 76.34, that is equal to 258.8. The value is 258.8 ohm inverse centimeter square mole inverse. That is direct question. If somebody use only lambda 0m Mg2 plus lambda 0m Cl minus, the answer is wrong, because one molecule of magnesium chloride contains 2 chlorine atoms. Next question, that is based on the second applications of Kohlrausch's law. That is the molar conductance. The molar conductance of a 0.001 molar acetic acid solution was found to be 48.15 ohm inverse centimeter square mole inverse. Lambda 0m CH3COOH is 390.6 ohm inverse centimeter square mole inverse. Calculate degree of dissociation. Calculate degree of dissociation of acetic acid. That is, here the concentration is given. That is, in addition to this, suppose you have to calculate, in addition to this degree of dissociation, you have to calculate the dissociation constant also. Then what is the expression? K equal to C alpha square divided by 1 minus alpha. That is the expression for dissociation constant. K equal to C alpha square divided by 1 minus alpha. Here the concentration is given 0.00. We get the value of alpha, 1 minus alpha. Then you get the dissociation constant. That is the second applications of Kohlrausch's law. Okay. Next is about the electrolytic cell and electrolysis. I think this is the last part of this lesson as per the new syllabus for this year. The remaining thing is about the cells, primary cell, secondary cell, fuel cell, corrosion, like that. That part is deleted, and this is the last part of the lesson, electrochemistry. And electrolysis. Electrolysis, the word electro means electricity, lysis means splitting. Splitting using electricity is called electrolysis. That is, the electrolysis is normally conducted in an electrolytic cell. It is a bad conductor of electricity. There are two metal rods which helps to connect with the external circuit, that is called electrode. The electrode that is connected to the positive terminal of the battery is called anode, while the other connected to the negative terminal is called a cathode. The electrode is normally immersed or dipped in electrolyte. It is dipped in electrolytes. An electrolyte is a substance whose aqueous solution or in molten state melt, conduct electricity, and simultaneously at the same time they undergo dissociation. Suppose here we take molten sodium chloride. If we take molten sodium chloride, by the passage of this electricity, don't get confused, that is in an electrochemical cell, anode always carries negative charge, while electrolytic cell, anode carries positive charge. In electrolytic cell, both the electrodes are inserted in the same container, but in electrochemical cell both are in separate half cell or redox coupled. Or by the passage of this electric current, sodium chloride undergo dissociation to form Na plus and Cl minus. As a result, the ions migrate towards the electrodes of opposite charge. The ions that migrate towards the anode is called anion, while the ion migrate towards cathode is called a cation. Anion and the cation. At the cathode, reduction takes place. Na plus plus 1 electron gives Na. That is, reduction means addition of electron. And at the anode, Cl minus gives Cl plus 1 electron, that is oxidation. Normally, since chlorine is diatomic, 2 Cl minus gives Cl2 plus 2 electron. That means by the passage of this electricity, electrolyte undergo dissociation and the oppositely charged ions are formed. These ions migrate towards electrodes of opposite charge. And at the respective electrode, they get discharged or they get neutralized. Then, what is the difference, or is there any difference in the electrolysis of molten sodium chloride as well as aqueous sodium chloride? Molten sodium chloride as well as aqueous sodium chloride. And molten means melt. That contains only Na plus and Cl minus ions in the case of molten sodium chloride. Obviously, Na plus undergo reduction and Cl minus undergo oxidation. Okay? No doubt. Only one cation and one anion. But If we take aqueous sodium chloride contains Na plus Cl minus H plus and OH minus. Na plus Cl minus H plus and OH minus. Na plus and Cl minus. Definitely that sodium chloride contains Na plus and Cl minus. Since it is an aqueous solution, water dissociate to gives H plus and OH minus. Clear? If it is molten sodium chloride, no other factors interfere the mobility of ions because that contains only Na plus and Cl minus ions. But that is not case with aqueous NaCl. Aqueous NaCl means sodium chloride dissolves in water. After the dissolution of sodium chloride in water, it contains Na plus Cl minus H plus and OH minus ions. Okay. Here there are two cations and two anions. Then normally a competition arises between the two ions of same category. Here there are two cations and two anions. Then which ions will be deposited or liberated at the cathode, or which ions will be liberated at the anode, like that. And the discharge or the production of respective elements at the electrode, anode and cathode, depends upon the discharge potential. Out of Na plus and H plus, the discharge potential of hydrogen is high. Therefore, hydrogen gas is liberated at the cathode out of Na plus and H plus. These are the two cations, and H plus ions undergo reduction quickly than Na plus ions. Therefore, hydrogen gas is liberated at the cathode, while Cl minus and OH minus, the discharge potential is less for chloride ion, or it easily undergo oxidation, and at the anode chlorine gas is liberated. Chlorine gas is liberated. And in the electrolytic cell, Na plus combines with the OH minus, that is the one cation Na plus and one anion Cl minus remains in the electrolytic cell. They combine to form NaOH as the secondary product. NaOH as the secondary product. Okay? That is about electrolysis. And once more, the important topic that we discussed today, one is about Colruyt's law. Colruyt's law always start with this variation of conductivity or molar conductivity with the dilution. Strong electrolyte on dilution, it reaches a maximum value that is called a limiting molar conductivity or molar conductivity at infinite dilution. While in the case of a weak electrolyte, on dilution the dissociation increases to a certain extent, but it never reaches a maximum value. Therefore, the lambda 0m value of weak electrolyte is calculated indirectly. Then, indirect method for the calculation of lambda 0m value of weak electrolyte is by applying Colruyt's law. This law states that the limiting molar conductivity of an electrolyte is taken as the sum of the ionic conductivities of anions and cations. And mainly there are two applications for this Colruyt's law. One is, it helps to calculate lambda 0m value of weak electrolyte if you are provided with the lambda 0m value of strong electrolyte, whose lambda 0m value can be directly obtained. By getting the lambda 0m value of strong electrolyte, you can find out the lambda 0 value of weak electrolyte. And the second one is, it helps to calculate the degree of dissociation. Degree of dissociation means it is the fraction of total number of moles that undergo dissociation. By knowing alpha, you can calculate the dissociation constant also, that is K equal to C alpha square divided by 1 minus alpha. And next is about the electrolysis, splitting using electrolysis, different terms in electrolysis, and the difference in the nature of electrolysis of aqueous as well as molten electrolyte. Okay? Thank you. The remaining thing, that is the law of electrolysis introduced by Michael Faraday, that we'll discuss in the next session. Thank you.